Alright, this is a first in a series of 4 videos. The first one will go over the area formulas, then surface area, then volume, and the final video will put it all together and looking at complex forms and shapes, 2-dimensional and 3-dimensional. So let's just start simple here with area formulas. In these videos I'm not going to explain exactly why things are the way they are. I'm just going after the how. How do you find the area of these shapes? So really quickly, some of this, in fact many of these things you've seen over and over and over again. So here's the area of a rectangle, and that's the area is equal to the base times the height. So in this case it'd be 11 times 6. So the area of this rectangle is 66 square units, whatever that is, if it's inches squared or just units squared. But for the sake of pure math, oftentimes we just write the number. In this case here, actually, I forgot to write the number that should be on the bottom here. Let's call that 7. Okay, so the area of a triangle is like actually two parallelograms put together, or sometimes 2 rectangles, depending on the triangle. So its formula is actually just half of what it is for a rectangle and a parallelogram. So in this case, you have a side that's a base, and it could be any side. And then from that measured perpendicularly to the point across from it. So if this is the base, then the height is measured from this side perpendicularly to that point across from it. If I treated this as the base, I would have to go perpendicularly to the point there, which might sometimes mean that you have to go outside of the shape. But in this case, it's set up really nice and easy. So I just plug this in. 1/2 times the base times the height is 14. So 1/2 times 4 times 7. Okay, area of a circle. You've got to find the radius. Again, they might give you that information in a convoluted way that you got to find it, but in this case, really simple. The radius is 3. You square that, multiply by pi. I'm actually just going to write 9 pi because a lot of times, especially as you move more advanced topics, you actually just leave the pi. But if it asks you to round to the 10th, then go ahead and do that on your calculator and round to the 10th. We'll come back to the regular polygon in a second. Here's a parallelogram. You'll notice the formula is exactly the same as a rectangle. But again, when we measure the height, it's always perpendicular to the base. So in a rectangle's case, that's easy because the 2 legs are already perpendicular. In a parallelogram where it's not perpendicular, I'm going to have to measure the height that is perpendicular to the side that I do know the length of. So I could call this the base, but then I would have to find a perpendicular line to the other side. In this case, it's really easy. Here's my base, perpendicular up to that. So my base is 10, because remember that the sides of the parallelogram are the same, and my height is 7. So you multiply those together, and you get an area of 70. Okay? And then finally, before we get to this massive one, the trapezoid, where 2 sides are parallel. And this is basically just kind of, you're taking the average. You know, if it was a parallelogram with a base of 4, or if it was a parallelogram with a base of 12, those would have 2 different areas. Well, the trapezoid is kind of the average of those 2 parallelograms, if that makes sense. So you take the average of the 2 bases, so in this case 4 and 12, that's what it says. To add them and divide by 2 is to take the average. So 4 plus 12 is 16, divide by 2 is 8. So this would be 8 times the perpendicular height, just like you did with the parallelogram. And so 8 times 5, that would make our area equal 40. So once again, on a trapezoid, you're just taking the average of the bases and multiplying by the perpendicular height. Okay, now everyone's favorite, regular polygons. Remember, it has to be a regular polygon to work here, which means all the sides have to be the same and all the angles have to be the same. So in this case, they're going to tell you often, hey, this is a regular polygon. And you'll notice there's some letters here you might not necessarily recognize right away. A stands for, actually, I'm not even sure how to pronounce it. Apothegm, comes from Greek. And it's kind of like the radius in a way. It's the distance from the center of the polygon perpendicular to one of the sides. So from the center of the regular polygon, drawing perpendicularly to one of the sides is this value. And then P, this stands for perimeter. So the distance all the way around. And oftentimes, they're only going to give you one because they don't need to give you the other. You can actually convert, and I'll show you how to do that. So in this case, if this is 6 and it's regular, that means that all of these are 6. So the perimeter adds up to 30. Well, we can use also, we can find out what the angle measure is because it's regular. First, we find out what the total angle is. And if you remember, a triangle is 180. A quadrilateral is 360, and it goes up by 180 each time. This has 5 sides. So the total angle measure, or the sum of all the angle measures, in this case is 540. And how many of them are there? There are 1, 2, 3, 4, 5. So if you divide by 5, each one of these angles is 108 degrees. Now, if you were to draw a triangle using the apothem or the apothem or however that's pronounced, what will happen is you can draw a right triangle like this. It will split, it will bisect. It will bisect the side here, so this would be 3. It'll bisect this angle, so instead of 108, it's half of that, 54, which would also make this one right here 36. And let me draw that triangle a lot bigger. So here's what I don't know. I know this is 3, I know this is 54, and I know this is 36. And so I can use my trig ratios to solve for this. So the sine of, and actually let's do the sine of 54. You can use any trig one that works for you, but I'm going to do the sine of 54. Sine of 54, remember the sine is the opposite. Actually, I'm not going to use sine. What am I saying? I don't have the hypotenuse. I don't know what this is, so I'm not going to use something with the hypotenuse in it. Sine has hypotenuse. It's opposite over hypotenuse. Cosine has adjacent over hypotenuse. Which one doesn't have the hypotenuse in it? If you said tangent, that's the one. Okay? So actually, I'm going to use tangent. So sorry for that confusion. I'm going to use the tangent of 54. Tangent is opposite over adjacent. So that would be a over 3. So I'm going to use my calculator. I'm going to type in the tangent of 54. And then what I'll do later is multiply by 3. So why don't you go ahead and do that now and see, and come back. And that'll tell you what the apothem or apothem, again, I'm actually not sure how to pronounce it, is. And then you're going to plug this number in here. And then we already know the perimeter is 30. You're going to plug that number in. And you're calculate the whole thing. So what you're going to do is in just a second, you're going to pause, find out what A is, plug it in with P, and then find out the area of the regular polygon, in this case the pentagon. All right? Go ahead and pause now and do it yourself.